All right, let's dive right in. We're tackling Spring Boot today. Specifically, how to build and deploy an application using a PostgreSQL database.
Sounds good.
We had a listener write in with a really comprehensive guide.
Yeah.
So we're going to break it all down. We're going to make it make sense even if you've never worked with Spring Boot before.
Right.
And the cool thing about this guide is that it really focuses on the why behind every step. So
Definitely.
you don't just learn how to do it, but you understand the logic behind each decision.
Exactly. That way you can take those principles and apply them to any Spring Boot project.
Love it. So right off the bat, this guide lays out a 3-tier architecture: controller, service, and repository. Why this separation? It seems like extra work at first.
You know, at first glance, it might seem like you're adding complexity, but trust me, it pays off big time in the long run. Think of it this way. Imagine trying to build a house without separating the plumbing, the electrical, and the structural element.
Oh, a complete disaster.
Exactly. A nightmare to maintain, right? Well, the 3-tier architecture is kind of like that for software.
Okay, I'm starting to see the analogy.
The controller is like the front door, handling all the incoming requests from users. Then you've got the service layer, which is where all the core logic lives, like making sure the data's processed correctly, all the behind-the-scenes stuff.
I see, so it's kind of like the brains of the operation.
Exactly. And finally, the repository. That's how we communicate with the database, kind of like the foundation of the house.
Okay, so it's all about keeping things organized and maintainable. But where do we even start building this thing? Where do we begin?
Well, the guide recommends starting with Spring Initializer. It's a super handy tool that sets up the basic project structure for you, takes care of all the boilerplate code.
Nice. So it's like having a pre-built frame for our house.
Exactly. And then we need to add some specific ingredients. Dependencies like Spring Web for handling web requests, Spring Data JPA for database interactions.
And of course the PostgreSQL driver, since we're working with a PostgreSQL database.
You got it.
All right, so we've got our foundation and the essential tools. What about configuration? I remember seeing a file called application.properties. What role does that play?
That's like the control panel for your application. It's where you specify important details, like database connection settings.
Okay, so it's kind of like fine-tuning the settings to get everything running smoothly.
Exactly. You're making sure all the parts work together harmoniously.
Makes sense. Now, what about the model class? What exactly is that?
The model class is basically a blueprint for your data. It defines how your data will be structured in the database.
Oh, so it's like defining the columns in a spreadsheet or the fields in a form.
Precisely. Like if you're building an application to manage users, your user model might have attributes like name, email, password, and so on.
Right, and I remember seeing annotations in the guide, things like at entity and at id. What are those all about?
Those are like labels or instructions for Spring. At entity tells Spring that this class represents a table in your database.
Ah, okay. And at I?
That one designates the primary key field, which is a unique identifier for each record.
Got it. So it's like each user having a unique ID number.
Precisely. Makes it easy to find and manage individual records.
That makes sense. It's like giving each house a unique address. Now, what about the repository interface? How does that fit into this whole layered structure?
The repository. That's the bridge between your application and the database. It handles all the interactions with the database, things like saving data, fetching data, deleting data.
Sounds pretty important.
Yeah.
But I've never really worked with databases before. What's actually involved in those interactions?
Well, traditionally, you'd have to write these things called SQL queries, which are specific commands for retrieving or manipulating data in the database.
Oh, that sounds complicated.
It can be, especially for beginners. But this is where Spring Data JPA comes in and saves the day. It provides pre-built methods for common database operations, so you don't have to write all those complex SQL queries from scratch.
Wow, that is really helpful.
Definitely simplifies things a lot. It's like having a translator that helps you communicate with the database effortlessly.
So we've got the model, the repository handling database interactions. What's next?
Next up is the service layer. That's where all the magic happens, all the business logic and error checking.
Error checking. Like what kind of things?
Well, for example, let's say you're building a user registration system. You'd want to make sure each user has a unique email address, right?
Definitely.
So the service layer can handle that by checking if an email already exists before creating a new user, prevents duplicates, and keeps your data clean.
Ah, I see. That's pretty important. So the service layer is kind of like a quality control checkpoint, making sure everything is running smoothly.
Yeah, that's a good way to put it. It ensures the integrity of your data and the overall functionality of your application.
All right, so we've covered the model, repository, and service layers. What's the final piece of this puzzle?
The final piece bringing it all together is the controller.
All right, so the controller is going to tie everything together.
It's like the conductor of the orchestra, coordinating everything, bringing it all together.
I like that analogy. So what exactly does the controller do?
Basically, it's the entry point for all the requests coming into your application. It decides where to send those requests and how to respond to them.
So if a user wants to register a new account, the controller would handle that.
Precisely. It receives the user's information, passes it along to the service layer for processing, and then sends back a confirmation or an error message, depending on what happens.
Okay, I think I'm starting to get the big picture here,
Mm-hmm.
but I'm still a little fuzzy on some of the details.
That's totally understandable. This is just an overview. We'll dive deeper into each layer in the upcoming parts.
Sounds good. I'm already excited to learn more.
Me too.
So for our listeners, be sure to join us for the next part, where we'll really dig into the nitty-gritty of each layer and start building out our application. And if you're following along with the guide, feel free to pause and explore the code examples as we go.
Yeah, that's a great idea.
All right, we'll see you in the next part.
See you there.
Okay, so the controller. How does it actually bring the application to life?
Well, the controller, it's the entry point for all those incoming requests to the application.
So it's like the gatekeeper.
Yeah, kind of.
Yeah.
It directs those requests to the right service methods and then sends back responses to the user.
Okay, so like if a user wants to register a new account.
Exactly. The controller would receive all the user details, pass them along to the service layer to do all the processing, and then, based on what happens, send back a confirmation or maybe an error message.
I see. So it's kind of like a middleman between the user and the inner workings of the application?
Yeah, you could say that. The guide mentions something called API endpoints.
Yeah, API endpoints. What are those exactly?
They're specific URLs that basically expose your application's functionality to the outside world. Think of them like entry points into our house.
Okay, so like different doors for different purposes.
Exactly. The controller defines these endpoints and maps them to methods in the service layer. For example, app users. That might be an endpoint for creating a new user, and it would be handled by a create user method in the service.
So if I send a request to a Pive users, the controller would say, okay, this is for creating a user. Let me pass it along to the create user method.
Yeah, that's the idea. And the service would do its thing, interact with the repository to save the data to the database.
It's all starting to click now.
Yeah.
So with all this in place, how do we actually package this application up, get it ready for deployment?
Good question. The guide talks about creating a JAR file.
Right, JAR file. To be honest, I'm not really sure what that is.
It stands for Java Archive. Basically, it's like a zip file, a compressed package that includes all your compiled code and any other resources.
Okay, so it's like packing up all the building materials for our house into a neat little container.
Exactly. Ready to be shipped and assembled wherever we need it.
Makes sense. And then the guide goes a step further with Docker.
Docker. It's like a game changer for deployments.
Okay, I've heard of Docker, but never really understood what it does.
So Docker, it lets you create a container. It's like a self-contained environment for your application. Imagine taking that JAR file we talked about, putting it in a box with its own little version of Java, all the libraries it needs to run.
So it's like creating a mini version of your whole development environment.
Precisely. And the beauty of this is that it guarantees that the application runs the same way, no matter where it's deployed.
That's pretty amazing. Solves the whole, it works on my machine problem, right?
Exactly. No more compatibility issues. Docker takes care of all that.
So how do we actually create one of these Docker images?
We use something called a Docker file. It's a simple text file with instructions on how to build the image.
So it's like a recipe for Docker.
Exactly. It tells Docker what base image to use, which files to copy, what commands to run to get everything set up.
Okay, so we've got our Docker image. What happens next? Where do we deploy it?
The guide recommends AWS, specifically a service called Kubernetes.
Kubernetes, the orchestra conductor. I remember that. How does it fit into this whole deployment picture?
Okay, so imagine Kubernetes as a conductor, and it's managing this whole orchestra of servers. It takes care of deploying your application across multiple machines, making sure everything's running smoothly. Scales it up or down as needed.
So it takes care of all the complex infrastructure stuff, letting developers focus on the application itself.
Exactly. But first, we need to get our Docker image up to AWS. We do that by pushing it to a repository like AWS ECR, which stands for Elastic Container Registry.
So ECR is like a library for Docker images.
Yeah, you can think of it that way, like a central hub where you store your images, making them available for deployment.
Okay, so we push our image to ECR, And then Kubernetes takes over.
You got it. We give Kubernetes instructions on how to deploy our application using YAML files. Think of YAML files as the conductor's sheet music.
They tell Kubernetes what to do.
Yeah, like how many instances of the application to run, how they should be exposed to the outside world, what resources they need.
Got it. YAML files are like the blueprint for the deployment. So Kubernetes reads these instructions, pulls the image from ECR, and makes our application live, right?
Pretty much. And the cool thing is that Kubernetes also handles things like load balancing. So if you have multiple instances of your application running, it makes sure incoming requests are distributed evenly across them, so your application stays responsive even under heavy traffic.
It's incredible how much Kubernetes is doing behind the scenes. Makes deployment so much smoother.
It really does. Takes care of all the heavy lifting for us. But with all this focus on deployment and infrastructure, we kind of forgot about one crucial aspect, right? Error checking and logging.
Oh, right. Yeah, those are important too. Why are they so crucial?
Well, no software is perfect, right? Things are bound to go wrong sometimes. Error checking, that helps us anticipate those unexpected situations and handle them gracefully. Logging, on the other hand, gives us a detailed record of what's going on inside the application, which is super helpful for troubleshooting and debugging.
Okay, so error checking is like having a safety net. And logging is like having a black box recorder.
Exactly. And Spring Boot makes both of these super easy to implement. For error handling, we can use a controller advice. It's kind of like a central error handling unit that intercepts exceptions thrown by your application and provides appropriate responses to the user.
So it's like a customer service representative that steps in when something goes wrong and tries to smooth things over.
Yeah, a good analogy. And for logging, Spring Boot gives you this built-in logging framework, so you can record all kinds of events, from user actions to system-level details.
I remember seeing something in the guide about logging levels.
Right. The logging level basically controls how much detail gets logged.
Yeah.
The INFO level, the one mentioned in the guide, it gives you a good balance. Enough information to be useful without overwhelming you with too much detail.
So it's like choosing the right zoom level on a map. Too much detail can be confusing, too little, and you miss important information.
Yeah, that's a good way to think about it. And you can customize the output format of the logs, send them to a file, a database, or even a dedicated logging service.
Oh, that's really flexible.
It is. It gives you a lot of control over how you manage your application logs.
So we've covered a lot of ground here. Layered architecture, packaging with Docker, deploying with Kubernetes, error checking, logging.
Yeah.
What's next? How do we actually see our application in action?
Right. We got so caught up in all the deployment stuff, we almost forgot about these unsung heroes. Error checking and logging. They're pretty important, right?
Oh, they are.
Yeah.
Absolutely crucial if you want a robust, reliable application.
Okay, remind me again why they matter so much.
Okay, well, no software is perfect. Things are going to go wrong at some point.
Yarna.
Error checking is like having that safety net. It
Yeah.
lets you anticipate those hiccups, those unexpected situations,
Yeah.
and handle them gracefully without crashing the whole system. And logging. That's like having a black box. Gives you that detailed record of everything that's happening.
Makes it easier to troubleshoot. It's exacta.
I see. So Spring Boot gives us all the tools we need to handle these things.
It does. Spring Boot has great support for both exception handling, which is the error checking part, and logging.
So for exception handling, what do we use?
Well, we can use something called @controller advice.
At controller advice.
Yeah, it's kind of like a central error handling unit. It intercepts those exceptions
Okay.
and provides the right responses to the user.
So it's like damage control.
Kinda. It tries to make sure the user has a smooth experience even when things go wrong under the hood.
I like that. What about logging? How does Spring Boot handle that?
It has this built-in logging framework. Really robust. You can log all sorts of things, user actions, system details, all that.
And we can control how much detail we log, right?
Yeah, with the logging levels, remember the guide mentioned the INFO level?
Yeah.
That's usually a good balance. You get enough information without being overwhelmed by too much detail.
And where do these logs actually go?
Well, you can customize that. Send them to a file, a database, or even a dedicated logging service.
So much flexibility. It's amazing how much thought goes into all these aspects of building an application.
It really is. It's not just about writing code. It's about creating a well-rounded system that can handle anything.
I'm really starting to appreciate that. But after this whole journey, after all this building and deploying, I'm itching to see our creation come to life. How do we access the live application?
Well, remember those YAML files we use for Kubernetes? They're the key.
Okay.
When we deployed our app, Kubernetes created what's called a service. Acts like a load balancer, distributing incoming traffic.
It's like the front desk at our restaurant, directing customers to available tables.
That's a great analogy. This service also provides a public IP address. That's what we use to access our app from anywhere.
Ah, our app's unique address on the internet. How do we find it?
You can use the command kubectl-get svc.
Kubectl-get svc.
Yeah, that'll give you the details of the service, including the IP address. Just plug that into a web browser, and boom, there's your app, live in the cloud.
Wow, from a blank slate to a live application, it's incredible to see it all come together.
It is. It's a testament to the power of these modern tools and techniques. Spring Boot, Docker, Kubernetes, they really make a difference.
It's been an amazing journey exploring this world of Spring Boot. We started with the basics, that layered architecture.
Yeah.
Then we packaged everything with Docker, deployed to the cloud with Kubernetes, even covered error checking and logging.
It's been quite a ride.
It has. Our listeners are probably feeling pretty empowered right now, ready to build their own Spring Boot applications.
I hope so. And the best way to learn is to just dive in, get your hands dirty. There are so many resources available online, tutorials, documentation, open source projects.
That's true. The online community is a huge help.
Absolutely. And remember, the learning never stops in this field. There's always something new to learn.
That's what keeps it exciting. Well, it's been fantastic exploring the world of Spring Boot with you.
Likewise, I've really enjoyed our conversation.
And to all our listeners out there, if you're feeling inspired, don't wait. Start building. Even a small project can teach you so much.
Absolutely. The most important step is to just start.
And if you ever get stuck, reach out. There's a whole community of developers out there ready to help. Until next time, happy coding.